In this lecture, we're going to look at 4 self-test problems from the textbook. So let me quickly rephrase the first one. So you and 2 friends, 3 people in total, go to Burger King to order food. The chance for an order to be correctly filled is 82.3%. So the first question asks, what is the probability that all 3 orders will be filled correctly? So this problem is similar to asking, if you toss a coin 3 times, what is the chance of getting 3 heads in a row? The underlying variable is the result of counting how many heads produced from tossing a coin a fixed amount of time. Any random quantity coming out of this process follows the so-called binomial distribution. Let's now look at the Excel function that provides the calculation for binomial distribution. Let me first point out the parallels between the example of coin toss and the official terminology in statistics for binomial distribution. The notion of a trial is equivalent to the notion of a coin toss, or in this example, equivalently is the same notion of an order for food. So officially, a trial can only have either success or failures as one of the 2 outcomes. And equivalently, for a coin toss, you can only have either heads or tails as 2 of the possible outcomes. And in this example, for an order, it can only be either correctly filled or incorrectly filled. So number of success. So the number of success in our example refers to how many orders out of the total 3 orders are filled correctly. Trials, because we have 3 people ordering, therefore equivalently we have 3 trials, or again, as another way to look at it is to think of this is equivalent to toss 3 coins. Probability of success in this case is indicated here as 82.3%. Cumulative is the 4th parameters that we need to specify for this function. And if you specify it as true, the function will return cumulative probability. And then if you specify it as false, it's going to return you the probability itself. Just to make sure we are really clear of these notions, let me write down the algebraic notation. So if we define x as the variable which follows the binomial distribution, and the distribution itself is described by 2 parameters. The first one is number of trials. The second one is the chance of success. So in this case, number of trials is 3 because we have 3 people ordering food. Chance of success is 0.823. Now, the first question is asking, what is the probability for x to be equal 3? Now we can use the Excel function that I just introduced for this calculation. Binomial distribution. we get number of success, in this case 3. Number of trials, again, is 3 because we have 3 people ordering food. Probability of success is this number, 0.823. And in this case, we are asking for probability, not cumulative probability. Therefore, I would use false as the fourth argument value. And this should give you the answer for part A. Now if I'm interested to know about, if I change this one from equal to less than or equal to, then I redefine this as the cumulative probability. So I just need to go back here and change the fourth argument from false to true. Now pause quickly and guess what the value should be. So in this case, the function is going to return a probability that tells you x is less than or equal to 3. Again, remember how many total trials. What is the number of total trials? It's 3. Okay, so the number should be 1. Correct? So in binomial distribution, the variable has a maximum value, which is the number of trials. So in this case, x cannot be greater than 3. Now let's look at the next problem. Let me quickly again rephrase this problem. So a manager is inspecting a batch of chocolate chip cookies. If the production process is in control, then the mean number of chocolate chips per cookie is 6. So in this case, what is the variable? So clearly it should be the number of chocolate chips in a cookie. And I would say equally clearly that variable is a discrete one because we are counting how many chocolate chips in a cookie. Now in this case, is there a maximum number of chips that a cookie can have? We know on average it should be 6, but it's unclear what the upper maximum value is. Maybe 40, maybe 100, depending on how big a cookie is and how small a chip is. So therefore, this is no longer a binomial distribution. In fact, this is called a Poisson distribution, controlled only by this one parameter, which is the mean number of that variable. Again, let me write down the setup algebraically to make it more concrete. In this case, we have a new variable. Again, we're going to use x to denote the variable. Now it follows a Poisson distribution, and the Poisson distribution is governed only by one parameter, which is the mean. In this case, equal to 6. So let's look at the first question asked. What is the probability that in any particular cookie being inspected, fewer than 5 chips will be found? So we are asking what is the probability of x to be fewer than 5, less than 5. And remember, this is a discrete variable, so it can only take on integer value. So probability of less than 5 is the same as probability of x being less than or equal to 4. So you should realize that this requires a cumulative probability calculation. So let's use let's use the Excel Poisson distribution function for this calculation. So now it takes three parameters. X is the value that the variable wants to take on. In this case, I will use 4 here. Mean is the only parameter that controls Poisson distribution. In this case, is 6. And as I indicated earlier, that I want to calculate a cumulative probability. Therefore, I should put true in this position. And this should be the answer for the first part of this question. So this function also allows us to quickly get a sense of the total distribution of this variable, or to satisfy your curiosity about how likely you would have, say, 20 chips in the cookie. So what we can do is, I'm gonna start from 0, 1, and I would create a list of number up to, say, 20. And then I'm gonna use the same function to calculate what is the probability of having no chips in the cookie. And again, at this time, I'm going to calculate not the cumulative probability. I want to calculate the probability for each value that the variable might take on. So I will put false here. And then I just need to drag this cell all the way down to 20. So this shows you that the chance of having no chips in the cookie is a really small number, 0.24%. And to have more than, say, 15 chips is again a really small number. To have 20 is a really small number. But in theory, there is probability of having 20 chips in the cookie. So while we are at it, let me also create another column that calculates the cumulative probability. So I'm gonna still choose this cell as the value of the variable. 6 is the parameter mean. In this case, instead of using false, I'm gonna use true. Now I'm gonna do the same thing. I would drag this all the way down, but again, take a guess how this column should behave differently. Yeah, it should increases and approaching 1 as the number increases. Exactly as we expected. Now let's move on to the third problem. Toby's trucking company determined that the distance traveled per truck per year is normally distributed. So now the variable is distance. And since distance is measured, therefore we know the variable in this case is a continuous variable. So it also tells you that it follows a normal distribution with the mean of 50,000 miles and a standard deviation of 12,000 miles. Okay, again, let me write down the algebraic notation. Now, where the variable x now follows a normal distribution. Now we know the mean notated as mu is 50,000 miles. The standard deviation is 12. So now again, x is no longer a discrete variable as the two previous examples that we just worked out. Problem A, what proportion of trucks can be expected to travel between 34 and 50,000 miles? It's always helpful when we have to deal with a normal distribution to draw a density function. So in this case, we know the distribution center at 50. We know one standard deviation is 12. So 50 plus 12 gives you 62. If you subtract 12 from 50, that should give you 38. So this is one standard deviation to the right, one standard deviation to the left. Now, so this question is asking what is the probability for x to be less than or equal to 50, but greater than or equal to 34. We can mark out the probability in this density function. So it will be 34 somewhere here and 50. So essentially we are trying to figure out what is the area, what is the size of this shaded area. And this is also equal to probability of x less than or equal to 50 minus because up to 50 would be the whole area, which is 50% because this is the center, and up to 34 will represent this white area. Therefore the difference, the two, is the shaded area. And that is the way that you need to use the cumulative distribution provided by Excel. Now let's take a look at the function itself. Normal distribution. So the x value in this case, let me show you how to calculate this part first. The x value is 34. The mean is 50. The standard deviation is 12. And yes, we want to calculate the cumulative probability. So this gives you 0.9 or 9%, which is the size of this white area. And you can either use the same formula to calculate this value, but of course I can guarantee it's going to give you 50% because this is the center. So the answer for part A should be this number subtracted from 0.5. Now I'm going to ask another question that might sound slightly more tricky. Now I'm going to carve out 5% at this right tail. So this area is 5%. Right? Now I want to figure out what is the corresponding mileage at this x-axis. So the interpretation of that mileage will be what? So I want to find out the mileage that corresponding to 5% probability to its right. So that tells me only 5% of trucks that traveled at a mileage that exceed that particular mileage that I don't know yet. So this tells you that we need to use the inverse cumulative probability. So I'm trying to find out what is this question mark value, so that the corresponding cumulative probability should be the complement of 5%, which is 95%. I want to find out what is that mileage value that corresponding to cumulative 95%. So once I find out that value, then I can tell you only 5% of trucks that traveled with the mileage that exceeds that particular value. And as we discussed in previous videos, that Excel does provide the inverse cumulative probability function for that as well, which is this one. It's called normal inverse. So now in this case, remember, it's a inverse cumulative probability. In this case, we need to enter 95% cumulative probability, and of course the mean and the standard deviation stays the same, 12. So this tells you that this particular point that we were looking for earlier, this value should be 69.74 miles. Again, the interpretation of that number is only 5% of trucks travel higher than that mileage. Now let's look at the first problem for this video. Now what is the variable? It says the time between arrivals of customers at a bank during noon to 1 p.m. hour has a uniform distribution of 0 to 120 seconds. So let's draw this out. You have noon to 1 p.m. Say this is one customer arriving. This is the next customer arriving. This is the third customer arriving. So the time between arrival, so this is the time, the interval between first and second arrival. This is the second and the third arrival. So the length of that arrival is the variable that we are dealing with. Again, it's time, therefore it's measured, therefore it's a continuous variable. And it tells you that it follows a uniform distribution. Uniform continuous distribution between 0 to 120 seconds. So again, we can, whenever it's a continuous variable, it's always helpful to draw the density function. Again, this is density, it's not probability. This is the variable. So 0 to 120 seconds. 0 here, 120 here. And it says it's uniform. That means the density is a flat line, it's even. So we know for this to be a density function, the area underneath the whole thing has to be 1. Right? So the area need to be 1. And therefore we can know what is actually this value. That value should be 1 over 120, because only that is the case we will be able to get a rectangle that has an area of 1. Now let's look at the first problem, A. What is the probability for x to be less than 120? As I indicated before in the earlier videos, this is the same as x less than or equal to 120, since the point probability for a continuous variable is 0. So basically I'm asking 20 here. I'm asking x less than or equal to 20. Sorry, this is 20. So I'm asking what is the probability for x to be less than 120, I'm asking what is the area in this heavy shaded area. So it will be a really simple calculation. 1 over 120 is the height. The width is 20. So that gives you 1 over 6, which is about 1/666. Right, so that is the answer for part A, and this actually does not require any Excel function.